A warm welcome to film number 5 in our double skin facade series, in which we consider the factors that affect the appearance of facing skin. Let's assume that you have decided to construct your facade as a double skin wall in which the facing skin will be built in fair-faced brickwork. This is because you want to emphasize the attractiveness of exposed brickwork. If you want to create an irregular masonry effect, you will have to use natural stone because prefabricated bricks and blocks always come with identical dimensions. Natural stone is not subject to the rules of modular coordination. In regular brick and block work, on the other hand, modular coordination does apply, dictated by the brick or block size. All length and height measurements, including wall length, column widths, and windows, are multiples of a half brick length or a full brick height. Ground plan dimensions are based on half brick lengths because the bricks are laid in patterns or bonds, generally a stretcher bond, in which the bricks are offset by half a brick. The half brick thickness of the facing skin limits the bonds that can be used, since bricks cannot be laid at right angles to the direction of the wall. Half bricks do exist, but they increase the cost of the wall and are better suited to the construction of solid rather than double skin walls. Thin facing skins are therefore generally built using a stretcher bond in which the bricks are offset by half a brick and which uses almost exclusively whole bricks. This is exactly how we built the facade of our Regensburg school, which is pictured on the left here. If a facing skin is built using natural stone, then an irregular bond with free stone lengths will be used. This means that though identical in terms of height and thickness, the stones are of different lengths. Solid bodies are subject to variations in length due to heat. Building materials and structures also shrink or expand as the temperature changes. As facing skins undergo these variations in length, they are constructed using expansion joints made of a permanently elastic material. Firstly, the walls must be separated from one another at the corners of the building to avoid damage caused by thermally induced tensile stresses. Here, the orientation of the facing skin, north, south, east, or west, is crucial. Wall lengths are also limited. Depending on the material and construction technique used for the facing skin, it may also be necessary to add further vertical expansion joints. The expansion joints generally run vertically and so interrupt the brick bond, as you can see on the left here. In our Berlin School of Hotel Management, we designed a meandering joint running in a sort of zigzag along both butt and bed joints. Although this does not spoil the look of the bond, it does result in a greater load on the joint, which will therefore have to be replaced more often. As you know from our lectures last semester, the dimensions of industrially produced bricks and blocks are generally based on the octametric system, that is to say 1/8 of a meter. Taking into account a 1 cm wide butt joint and a 1.2 cm high bed joint, a typical normal format brick is 24 cm long, 11.5 cm wide and 7.1 cm high. When a facing skin is built using this type of brick, the exterior dimensions of the building also have to follow the octametric system to prevent the appearance of the brick bond from being spoiled by cut bricks. If we take a look at the minimum and maximum layer thicknesses for double skin walls, we can see that the bricks in the facing skin must be 11.5 cm thick to follow the octametric system. The thickness of the insulating layer may mean that the dimensions of the load-bearing skin are no longer necessarily multiples of 1/8 of a meter. This can only be guaranteed if the insulating layer corresponds to the dimensions of an octametric cavity, that is to say, it is 13.5 cm or 26 cm thick. For the sake of simplicity, the insulating layer plus finger gap might measure 13.5 cm. The combined thickness of all the layers would therefore be 49 cm, exactly the same as a standard single skin wall. 11.5 cm facing skin plus 13.5 cm insulation plus 24 cm load-bearing layer. Summary. The purpose of constructing a facing skin in fair-faced brickwork is to emphasize the attractiveness of exposed brickwork. Facing skins can be made of irregular natural stone or regular masonry units. In regular brick and block work, the brick or block size is determined by modular coordination. As a facing skin is relatively thin, a stretcher bond with a half-brick offset is generally used to maximize the number of whole bricks and increase efficiency. Building materials and buildings are subject to variations in length due to heat expansion joints and therefore require vertical expansion joints. Our double skin facades series continues with film number 6. In it, we explain how transitions at the base of a building, windows and eaves are designed.